Okay, it's recording now.
Okay, great.
All right, we're going to go ahead and get started. Welcome to all of you. Many of your names and faces look familiar, so thanks for joining me again for this webinar. Here we're going to focus on how to deliver targeted and intensive intervention. And so my name is Sarah Powell. This is a picture of me. Oh, there we go. I'll get there soon. Before I was in my office every day, or in my home office every day. I just want to share a little bit. I have a website that shows a lot of the research that we are always conducting with students and teachers related to mathematics. So you can visit that website. It also has this presentation and the handouts for today if you want to download those. And if you have any questions, please feel free to email me by reaching out. I've already saw one email came in from earlier today, so I'm always happy to engage in conversations related to math and math learning. And also find me on Twitter. I'm at Sarah Powell PhD, and I only tweet about math things. So hopefully we can tweet about math things together. And I'd like to know just very briefly about you. I know a few of you have been with me for multiple sessions, but if you could just say what grade level you support and what math you teach, I'd love to know who's here with us in our last session for this afternoon. Dave, you're back. All right, Shannon, welcome. Welcome back. Betsy, you've been with us. Great, I love the principals and special education. Lori works with high school students, that's exciting. Oh, that's great. And intervention specialists, teaching assistants. All right, we've got a diverse group, but I think from everyone's descriptions, I think that all of you are really interested in helping students that experience difficulty with math. And so that's what we're going to focus on in this webinar is how do we deliver really strong math instruction to these students that are experiencing that math difficulty. So today we're going to talk about how do we deliver what we call the instructional platform. So in the webinar about how to design targeted intensive intervention, we talked about putting together this instructional platform based on thinking about critical content and evidence-based practices. And so a strong instructional platform includes 5 things, and we're going to deep dive into each of these 5 things in our next hour. The first is using explicit instructions. I'll talk quite a bit about that. The second is paying attention to the language that we use during intervention, so using precise mathematical language. The third is bringing in multiple representations, so helping students see and understand math in different ways. The fourth component is fluency building. So this is a strategy that we should use in our instructional platform every time we teach targeted or intensive intervention. And the fifth is problem solving instruction. So how do we help students set up and solve different types of word problems? So we're going to talk through each of these 5 components. This is really the cornerstone of our instructional platform. The instructional platform is our jumping off point for targeted intervention. And then in intensive intervention, we're going to adapt this instructional platform. So it's really important that we know how to deliver the components of the instructional platform to really be a good starting place and then a good adjustment as we make those adaptations. So we're going to talk about each of these 5 components in a little bit of detail. This is an overview to help you get ideas and juices flowing related to targeted and intensive intervention. And if you do want more information, I'm going to share some resources at the end of today. So let's first talk about explicit instruction. If you access the handouts for today, I made a little explicit instruction graphic organizer here. You're welcome to fill this in, or if you have it pulled up on your tablet, you're welcome to write on it or do whatever you want. But I'm going to use the explicit instruction model that comes from the National Center on Intensive Intervention. And this model has 3 big pieces to explicit instruction. We have modeling, we have practice, And then we have supports that occur during both modeling and practice. So let's talk about each of these big pieces in some detail. So when we think about using explicit instruction, we need to make sure that we're doing really good modeling. Good modeling starts off with stating a goal and why it's important. So what are we going to work on today and why is this important? A lot of times that goal relates to that critical content that we determined earlier. Like it is really essential that we work on place value. So why is it important that we work on place value and what are we going to do related to place value today? And then that statement of the goal and its importance is going to sound a little bit like this. So I have a turtle here that's going to be our teacher that's going to help us do some demonstrations today. And so maybe my teacher says, well, today we're going to learn about division, and that's important because sometimes you have to share objects with your friends. So you can see that that goal and why it's important is pretty brief, just 2 or 3 sentences, getting students to start to think about, well, here's what we're going to focus on today. Now then that goal and importance is followed by a modeling of steps. So the modeling of steps is led by the teacher, but it involves the student. So here I have my teacher turtle, but I also have my student seal, all right? So I've got the teacher and the student, and this is going to be how some modeling should occur. So perhaps the teacher is teaching the student or the seal, let's say addition of 26 plus 79. So here to model, the teacher would say, well, to solve 26 plus 79, I'm going to first decide about the operation. Do I have to add, subtract, multiply, or divide? And so then the student or a group of students would come in and say, oh, I see a plus sign, so we need to add. And then we're going to move on. So the teacher would say, well, yeah, that's right. The plus sign tells me to add. What is the sign that tells us to add? The plus sign. So you can see, even though the teacher is modeling here, the student or the group of students are actively involved in the modeling. And that's something we really need to emphasize in our explicit instruction. So here the teacher introduces that they're going to use the partial sum strategy. So first I'll add the tens, 20 plus 70. What's 20 plus 70? 20 plus 70 is 90, would say the students. Okay, well 20 plus 70 is 90. So I'll write 90 below this equal line. Where should I write this 90? You'll write 90 under the equal line. So you can see again this go back and forth between the teacher and the students. Then the teacher will say, okay, now I'm going to add 6 plus 9. What is 6 plus 9? Student says 6 plus 9 is equals 15. That's right, 6 plus 9 is 15. Where should I write the 15? Oh, you should write that under the equal line. And so now we'll add the partial sum. So the teacher introduces this idea, oh, I have to add 90 plus 15. So here the teacher says, well, 90 plus 15 is 105. So 26 plus 79 is 105. What's 26 plus 79? We get confirmation of the answer from the students. And so the modeling of the steps has occurred. Now there was a very, very simplified example with my teacher turtle and our student seal, but that's the modeling that should occur. Often it's going to be a little bit longer because our problems are going to be more involved and more complex, but it's a modeling of how to solve that problem. And then we follow that clear explanation by making sure we're using really strong examples that have been planned ahead of time. So we want to bring in examples. So here, if we're learning about division, I want to figure out, well, what examples of division do I want to provide? How do I want to show division? There's quite a few different ways that we could show division. And I also might want to bring in non-examples. So if the teacher is focusing on division, I might bring in the non-example of 25 minus 5. It looks a little bit like the division symbol. If the previous 2 problems that we modeled were division problems, students might answer that problem as 5. But this would be a good time for the teacher and the student to have a discussion of, well, when do I use my division strategy and when do I not use my division strategy? I wouldn't use my division strategy with a subtraction problem. So modeling is a statement of the goal and why it's important, a modeling of the steps to solve a problem. You might model 1 problem, you might model 3 problems or 6 problems. It really just depends upon how much modeling the students require and how much time you have in your lesson. And then you want to bring in examples and non-examples. And you also might want to bring in worked examples as well. That's another type of example to provide in here. So modeling a clear explanation with planned examples. So before I go on to the next thing, I'd like to think about, well, what are some of the strengths that are either yours with modeling, or what are some of the things that the teachers that you work with are, what are their strengths in terms of modeling math? And if you want to write those in the chat box, you're welcome to do that. If you don't want to write them, you don't have to. So some of the strengths that I see when I've observed teachers in terms of modeling, I'll see that teachers are really good with their planned examples. So thinking beforehand, which problems am I going to work on today? Think aloud. So Shannon says, good think alouds. That's a really important part of modeling. So to kind of see like, well, how would I solve this problem? How would I talk through it? And that think aloud is external at some point, but then it becomes internalized for students. I've seen some good think alouds as well. Pretty good examples. I've seen some good use of worked examples in the past. So moving on, we have our modeling, and then we combine that with practice. So practice is really where the learning of math occurs for students. The modeling is really important. That's a setup to kind of talk through, here's a way we could solve this problem, or here are multiple ways that we could solve this problem. But it really isn't until students are doing the mathematics that they are really learning the mathematics. So the modeling is the setup, and then the practice is where the true learning of mathematics occurs. So we need to make sure that we're providing lots of practice opportunities for the students in targeted intervention and in intensive intervention. We might do guided practice. So that's where teachers and students are practicing together. We do a lot of this in our intervention work, where the interventionist is sitting with a group of 4 students and they're all working on the same problem at the same time. So here the teacher might say, let's work on a problem together, and the teacher works on that problem with the student. We also have independent practice. This is where a student practices with teacher support, but it's more on the student. So here, the teacher is going to kind of turn it over to the student. So, okay, now you're going to work on this problem. Don't forget to use your word problem attack strategy. And then the student starts to work independently, but the teacher's still there to answer questions and to provide feedback. Of these two, guided practice is a real important part of that scaffolding, and that's the kind of practice we don't always see used when teachers are doing instruction in the math classroom. And Corinne, you kind of talked about this just in your comment. You said scaffolding, right? So modeling is a very tight part of the scaffold, and then we don't want to just go to independent practice and let the scaffold fall apart. Guided practice is like some teacher support, the teacher's still there being very helpful, but the student is starting to take ownership of the math and doing the math work. And so that guided practice is really essential for building student confidence, answering student questions, getting students to really understand, how do I solve this type of problem? And so I'll see a lot of classrooms that do some really good modeling and think alouds, and they're like, okay, now like try this with a partner, or try this on your own, where students probably would have benefited with a problem or 3 or 4, where the teacher and the students work on the problem together. So don't forget that guided practice. And it could be students practicing with each other, but often the students should practice at least one problem with the teacher before they turn to a partner and work on a problem, and then before they work on a problem on their own. So it's that scaffold being gently released for the teacher and the student. So I want you to think of what are ways that you could do guided practice, or how have you seen some of your teachers doing guided practice with their students? I'll give a few seconds for people to type in any answers, and then I'll share a few ways that I've seen guided practice used in classrooms. So in terms of guided practice, so I already said one of the ways in one of our research projects we do guided practice is all the students are sitting around the same table with the tutor, and they all have the same worksheet, you know, just something kind of like this. And they're like, okay, let's all do problem A. Let's read it together. Let's talk about what we need to figure out. Let's do this problem. And the interventionist is doing the writing and doing the drawing or using the manipulatives just like the student should be. So it's really a group collective of all of the students doing math together. I've also seen guided practice where the teacher is doing work on their document camera or on their tablet, and it's being displayed on the wall of a classroom. Right now, maybe you're teaching via Zoom or some other type of platform, and you're doing a problem and students see it, and they're doing the same problem with you, and you're checking their work. So there's a lot of different ways that you can do guided practice. You can also say, okay, let's do this problem. I'm going to do half of it with you, and then you're going to finish the rest of the problem. So guided practice doesn't mean that you, the teacher, always have to do the whole problem. Maybe you get started with steps A, B, and C, and then they go on and finish steps D and E on their own. So there's quite a few different ways that you can arrange guided practice to get students feeling really comfortable with the math before they start to do the math more independently. So we have our modeling and we have our practice, and that's really the heart of explicit instruction. So are you modeling? Do you provide a clear explanation with strong examples? And are you helping students practice in guided situations and in independent situations? That's what explicit instruction is all about. But you'll also notice that I guess it's here below both modeling and practice are supports. These are supports that we need to bring in to help students really engage and learn the mathematics. So we do these in both modeling and practice. So what are those supports? Oh, excuse me. What are those supports that we should be focused on? Well, first, we should ask what we call the right questions. So what are the questions that are going to get you to check for understanding? Those are going to just be low-level questions. And what are the questions that are going to get you to really understand what the students know and what they think about the math? So those are going to be high-level questions. A low-level question might be, well, what's 7 times 9? And the student seal says 63. A high-level question might say, well, why do you use 0 pairs? And you can see here with the student response that it's more than a one-word answer. It's really getting into, you know, what do they actually understand about 0 pairs? You want to ask the right questions frequently. So getting students to respond frequently and getting students to respond in a number of ways. Maybe you ask for a class-wide response, a partner response, a small group response, an individual response. Maybe students respond by showing you something with manipulatives or with their virtual manipulatives. Maybe students respond by writing something on their tablet or on a piece of paper. There are many, many, many different ways that students can respond, and you should employ a variety of ways to keep it novel and interesting. But during modeling and guided practice, we typically say that you should have students responding in some way every 30 to 60 seconds. So how are you engaging students in asking the right questions, and then how frequently are you getting students to respond? So here, my teacher turtle, I think he is here, I got him right there. You know, my teacher turtle might say, turn and discuss this formula for perimeter with your partner. That might be a way to get students to respond so that you can get feedback on how students understand the formula for perimeter. Then as you ask questions and you ask them frequently, you want to provide feedback, and this feedback should be specific. So you want to provide affirmative feedback when a student is doing something that's like, you know, going well. And you also want to provide corrective feedback. So the student makes a mistake or has a misunderstanding. The teacher should often say, hey, let's look at that again. Tell me, you know, how you added in this column. And then you'll want to move on from there. So affirmative feedback and corrective feedback. And then you also, as a teacher, you're in your supports, you want to be planned and organized. This is true in both modeling and practice. So maybe you're using manipulatives. So maybe it's like grab your bag of base 10 blocks as you walk in the classroom, and then we'll be ready to go. So those are the supports that should be in place so that you're maximizing your instructional time and that students are learning the most that they possibly can from the math instruction that we are working on. So one of the questions I want to ask you is, what are some of the ways you could improve supports? Do you think that you or the teachers you observe could ask more high-level questions? Do you think that you could be more specific with the feedback that you provide? Do you think that you could be more varied in the ways that you ask questions or ask students to respond? So what do you think are some of the ways that you could improve your supports? Errorless teaching, Dave, that's a good comment. Putting that in there. Conferencing, Nicole, and probably doing student conferencing. I would imagine both like student to teacher and student to student. And Shannon makes a comment about many times we want to get through the critical content, which we talked about in our last webinar, that we don't always allow time for students to do talking. I think that's right. And that's what I really want to emphasize. I'll kind of go to this on this. We'll go back here. In both modeling and practice, these supports are involving the student. So asking the questions, that means students are going to be talking about mathematics. Getting students to frequently respond, that means they should be responding frequently. Again, our rule of thumb is every 30 to 60 seconds. So if you can imagine, even just in a 20-minute session, maybe students have a minimum of 20 times to respond. Hopefully it's more than that. Providing feedback, that's not just the teacher talking at students, but saying, hey, how did you add these numbers in the tens column, and get students talking about that. And so you're right. It's like students don't always have the opportunity to talk, but it's through that talking and that communication that we can learn, well, what's going well, what might need some reteaching or redirection. And it's also helping students really start to internalize some of these problems and strategies and materials that we are using in math. So I agree is that we don't always think we have a lot of time for the talking, but if you set up your explicit instruction in this way, inherently students have to do a lot of communication and talking because I'm asking questions and giving feedback and we're doing guided practice. Like guided practice can't be done really without talking between the teacher and the students. Yeah. And Carolyn says, yeah, time is always a challenge. Yeah, engaging students the right way, asking questions. One of the things I'll do, Carolyn, both in our intervention development, so the research that we're doing in schools, and then also work with a lot of pre-service teachers who are student teaching and what they're doing, as especially for those high-level questions, design 3 to 5 high-level questions before you go and do the lesson. Now, you may not end up using all of them, but then if at some point it comes up about zero pairs or about place value or about regrouping, you can pull that question out of your back pocket and ask it. If you don't think through those high level questions before you start teaching, often it's hard to come up with them on the fly. Low level questions, those are easy to come up with quickly, but higher level questions often require just a little bit more thought before the lesson starts. So as I put these together, and I've talked about these, we've talked about modeling and practice, and my diagram really put these in this nice like 50-50 relationship with the supports occurring in both modeling and practice, but it's often a little bit sloppier than that. So if you're introducing something, you're likely going to take your session and do quite a bit more modeling, but still students are going to have an opportunity to practice, and you're still asking the right questions, getting students to frequently respond, and providing feedback. But if it's a review of material, you're probably going to do a little bit of modeling, and students have a lot more opportunity to do practice, but you'll still ask the right questions, get students to frequently respond, and provide feedback. And so it's never like clean, right? So on one day you might do 17 minutes of modeling and 13 minutes of practice. But then on the next day, maybe you do 6 minutes of modeling and 24 minutes of practice. And it's really just varies based on the content, where students are in learning that content, and who your students are. You also might have a small group of students where 2 of the students are ready to practice and you say, okay, you two go ahead and start practicing together, doing their guided practice together. And you might have 2 students in your group who you're like, hey, let me model another one, right? So you might even have a difference in how modeling and practice is presented, even within a small group of students. So really being flexible with this modeling and practice, and it doesn't have to be half the time we do modeling or half the time we do practice. So we've got a basic understanding of our explicit instruction. And so now I want to add to that. That is the foundation for targeted and intensive intervention. But now we're going to add to that and add our 4 other components to our instructional platform. So our second component is the use of precise language. And this is really embedded within explicit instruction, but we've learned that students that experience math difficulty really struggle with the language of math. So I want to pull it out here and give it a little bit of time on its own so that you really understand how important it is to be precise with your mathematical language. So this is just data from a study that we did just about 2 years ago where we looked at several different glossaries from math textbooks, and we just counted the terms in those glossaries. We removed all the duplicates to say, okay, well, how many math words or math terms is your typical 1st or 7th grade student responsible for? And the numbers are pretty high. So in grades K1 and 2, your typical kindergartner, 1st and 2nd grader, in their mathematics textbook, they'll be kind of responsible for either knowing, using, or learning anywhere from around 105 to 130 different math terms. That's a lot, even at kindergarten, if you really had to guess how many terms students are responsible for. And I say terms because some of these might not be single words. Some of them might be things like make 10 or number sentence or associative property. A lot of words are actually 2 or more words. A lot of terms are 2 or more words. In 3rd grade, we see a huge increase in terms of what students are responsible for in terms of mathematical language because we introduce multiplication, division, and fractions in 3rd grade. So here, 3rd, 4th, and 5th grade, students are responsible for knowing anywhere from 3 to 400 terms. And then we see another jump up in 6th, 7th, and 8th grade. So here the numbers are from the low 400s to the low 500s in terms of terms that students might see in a textbook, might hear their teacher say, might hear a video say, might hear from a peer, might be in their math writing. There's so many different ways that students can see the language of mathematics, and there's just a lot of terms. And so we need to be very focused and precise with our math language when we're using our explicit instruction, because students need to learn the math language, they need to hear it used properly, and then they need opportunities to engage in it. So that's where asking the right questions and getting feedback and engaging students in discourse, that's where they're going to get the opportunity to use that math language. So as I think about math language, I think that students have to listen to a lot of math language, either through videos or through peers or through teachers. Students have to speak the math language. So if you ask questions and you're talking about denominators, students are speaking about denominators. Students have to read a lot in math, even if they're reading closed captioning on a video, or if they're reading in a textbook or reading in a book or reading on a worksheet. There's a lot of language that students have to read. Reading is huge on high stakes standardized tests. And in many cases, and I believe this is actually true in Pennsylvania, students have to write about mathematics. So they not only have to solve math problems, but they have to be able to write about how they solve this problem, or they have to make a case for 2 different ways to solve a problem or something like that. And all of this involves a really strong understanding of the vocabulary of mathematics. So we need to ensure that students have opportunities to learn the vocabulary of mathematics, and that's often couched within explicit instruction. So I've put together a few articles about this. There are also others out there. If you'd like these articles, just send me an email and I'll send them along to you. But the idea is about we need to really be focused with our language, and so we kind of play an activity called Instead of That, Say This. And so I'm going to give a few examples, and then I'd like you to share an example if you can come up with one. So instead of asking students for this number, what number is in the tens place, we should really ask what digit is in the tens place. The number here is 135. The digit that we're focused on with our question is 3, or the tens place. Instead of talking in comparisons about this alligator or crocodile that's eating a bigger number, we should be mathematically precise and talk about is less than or is greater than. Instead of saying, oh, I carry or I borrow, we should say, oh, I regroup or I trade or I exchange. Those are more mathematically grounded terms. Instead of saying top number and bottom number, we should say numerator and denominator. Instead of asking students to reduce a fraction, which might signal a decrease in the value of the fraction, we should ask students to rename or simplify or find an equivalent fraction. Instead of calling that the point, it's actually not a point, it's the vertex. Instead of saying that something is a flip, a slide, or a turn, we should use the mathematical terms of reflection, translation, and rotation. So I want you to think of an example that either you've used and you kind of caught yourself on, or you've seen other teachers, but instead of saying blank, say something. And so I'll put in one here. Whoops, I'm going to go back here. I'll type mine in here. But instead of saying answer, I might say sum, or I could say product or difference or quotient. So being a little bit generic with answer, but being more mathematically precise with sum. And if anyone else has another one that they would like to share, this would be a great opportunity to do so. So some other examples that I can think about. So instead of saying, oh, yeah, say, what is the product of 5 times 4? That's great. Instead of what is the answer? Dave, that's a really good one. We could also think about those are not the numbers that we add, but those are the add-ins that we add. Yeah, instead of saying plus, we can say add. I think that there's a lot in geometry, like a lot of shortcuts. Like we might say this is a ball, but it's actually a sphere. The distance around a square, saying the perimeter around the square, that's a great one, Carolyn. I like that. We'll see if any others come up. But there's a lot of ways that we kind of informalize the language of mathematics. And in many ways, that means that students have to use the informal language and the formal language. And so in our targeted and intensive intervention, we want to make sure that students have an opportunity to hear the formal language of math, hear it used precisely, and that they hear it and that they also get to use that. So that isn't the top number, but that's the numerator. And let's talk about what that fraction means. So there's a lot of good examples that are coming in the chat box. So thank you so much for sharing those. So as we move with the precise language, just to keep in mind that we should use this formal math language and we should use these terms precisely so that students really have an opportunity to engage in math language in a proper way. So Corinne emphasizes my point here is a huge issue in high school when students don't know the math language. And I think it's a big issue at all grade levels, Corinne, but I think it compounds, right, across grade levels. And you know, you'll say something in one grade level. I had an example, I think it was like at second grade, where the teacher was talking about railroad tracks. And you're probably like, oh, well, I don't know what Sarah's talking about. Well, it was confusing for me too. She was talking about the equal sign there. But those second grade students, which is a weird, a weird example, so don't use that. But those second graders, they go to third grade, and I guarantee their third grade teacher is talking about the equal sign, not the railroad tracks. I also saw an example one time at eighth grade that, Corinne, this might be important for you. A teacher was talking about slope-intercept form and had this whole analogy about baking a cake. So y equaled something on the cake, and m and x and b, they all equaled putting this cake together. And it was a really cute story and a cute analogy. But then one of the teacher was like, so what's sloped intercept form? And one of the students was like, it's to bake a cake. Well, so I guarantee the ninth grade teacher is not talking about slope intercept form by baking a cake. They're just talking about slope intercept form. And so we might have these stories, but sometimes we get so wrapped up in this informal language and these informal stories that students don't really see the concepts that we're trying to teach. So yeah. So I've talked to the two teachers that I've heard say these things and kind of tried to push them on not using this informal language so much. And there is room for informal language and helping stories to help students understand these concepts, but continually emphasizing the formal language of math as well. I see this also in the early grades. We're not plussing, that's not even a word. We're adding. And so just like try not to make the language cutesy, but really pay attention to the precise language of math. So we have this precise language. So this has to be embedded within our instructional platform. And now I want to add to this the use of multiple representations. So by multiple representations, I mean the concrete, pictorial, and abstract. Sometimes people call this the concrete, representational, and abstract. But the idea here is that when we are teaching mathematics, that students have an opportunity to see math in different ways. This doesn't have to be for every problem every day, but students have an opportunity to at least see math in different ways, across the week or across a unit. Now, when we think about the concrete, that's often hands-on tools. So here are some examples of different hands-on tools that students might use. There are hundreds available, so this is just a small sampling. But here, if we are working with students in a physical environment, they have hands-on tools to touch and understand different math concepts. This is something I've been thinking through recently. We're not going to be tutoring in the fall, but we hope to be in schools doing some fourth grade intervention in the spring. And I think we're going to end up buying manipulative sets for each student so that, and they're clearly marked so that that student touches the same manipulative set time and time again instead of sharing across students. So I think that's something kind of new we'll have to think about, concrete manipulatives. But again, these are three-dimensional objects that students can touch and move around to help understand math ideas. With the pictorial, these are going to be flat images. So here I've got an image of bears to show addition or subtraction, images of place value, time, and money. We'll often have to interpret two-dimensional images of those. Here in the upper right-hand corner, I have a two-dimensional image of a three-dimensional object. So how do I interpret that? And we also have lots of virtual manipulatives that end up being two-dimensional. So here are examples of algebra tiles, Cuisenaire rods, and a geoboard. So many virtual manipulatives. In fact, I think there's a virtual manipulative for every concrete manipulative you've ever wanted to use, which is so exciting. And many of them are free or very low cost. I love this digital geoboard. That's a super great one. I loved that before even COVID-19 because I never liked the rubber bands flipping all around the classroom. But that geoboard's great for geometry. The geoboard's also great for showing fractions within the area representation of fractions. So lots of really great things you can do with these virtual manipulatives. But again, it's different ways for students to see the math above and beyond how they normally see the math, which is in the abstract. So that's the math presented with numerals and symbols. I'd also add the words of mathematics or the vocabulary of mathematics in written forms. But often we think about math in this way when this is math, and this is math. And so bringing in those multiple representations so that students can really understand, well, what does it mean to multiply? What does it mean to show a fraction? What does it mean to solve a two-step linear equation? There are visuals that can help with all of that. So I'd like to take a pause here and just ask for you to share with our group, what is one of your favorite multiple representations? I already said that the digital geoboard is one of my favorites. It's also totally free, which I think is great. But what are some of your multiple representations? And they might be drawings or graphic organizers or chart makers. There's lots of different things you could include here. So I'll say digital geoboard is one of my favorite virtual manipulatives. I used to go to the National Library for virtual manipulatives. Now I basically just find most of the virtual manipulatives on apps for tablets. Also, a lot of them can just be found for free online. In terms of my favorite physical manipulatives, fraction tiles are great. I love angle legs. I don't know if anybody, I'll write the link. These are like these plastic sticks that stick together. You can use them for fractions and for geometry. They're very cheap. Students really like working with them, and you can use them in first grade for shape me a triangle, and you can use them in 8th grade for figuring out the interior angles of a polygon. Interactive notebooks with foldables. I really like foldables, Corinne, where you can put those in there. And if you have an interactive notebook, that's also a great way to build a glossary for your mathematics vocabulary. I like the algebra tiles. I love algebra blocks. I think that we've got some really great algebra manipulatives that aren't always maximized to the greatest extent in the middle school grades. I like some of the three-dimensional figures that you can get that then have nets that you can see, fold those apart for the two-dimensional image and then put them back together for the three-dimensional. Those are really great for lateral and total surface area. And then some of the classics. I love the bears and the two-color counters, and base 10 blocks are never a bad thing. So there's just a lot of different multiple representations out there. Okay. All right, so I'm watching our clock and we're gonna move on here. So as we put together our instructional platform and we're delivering the instruction, we need to make sure we're using explicit instruction, pairing that with precise language, and then bringing in multiple representations. So each of those don't really stand alone. These as a collective are how we should deliver instruction. And then, as I said before, there are two strategies that really seem essential. And the research tells us that students who are in targeted intensive intervention often struggle with fluency and struggle with problem solving. So let's put in some daily strategies to help with fluency and problem solving. So in terms of fluency building, we want to focus on the 4 operations: adding, subtracting, multiplying, dividing. I'm going to focus quite a bit on fact fluency here, but also remember you want to go beyond that to fluency with fractions, fluency with integers, fluency with algebra. Fluency really you never stop building fluency. But when we're thinking about fluency activities, you want to do brief activities. These don't need to last 15 minutes of your 20-minute lesson. I'd say just a brief 1 to 2 minutes, but then you can do it, but it needs to occur every day. If you are going to do a 10-minute activity, maybe that only has to occur once a week, but a brief activity should occur every time you meet the students. So for example, we do a word problem intervention that meets 3 times a week with students, and the first 2 minutes of that intervention every day for 50 days starts with a fact warm-up for addition, subtraction, multiplication, and division facts. So you might just pull in some old activities, but goodies. So cover, copy, compare, taped problems, or this file folder activity. Flashcards are great. You can do some incremental rehearsal with your flashcards. You can do flashcards and graphing. This is an activity called Magic Squares, where my columns are going to sum to 12 and my row at the bottom is going to sum to 12. And now I'm going to figure out, well, what equals 8? 5 plus 1 is 6, and then 1 plus 3 is 4, and 3 plus 3 is 6. The diagonal does not work on the magic squares, but this is also a fluency building activity. You can play cards. There's quite a few card games where you can practice fluency, rolling dice, playing with dominoes. Wrap-ups are great. I like this game Smath and Moby. Moby is like the bananagrams of math, but you can create lots of different equations or expressions and practice your addition, subtraction, multiplication, and division. And there's also like tons of technology available. So there's really no limit to your fact fluency, but it should occur every day, and it should be brief. You don't have to spend a ton of time if you are going to do that every day. So that's just like a very brief overview of fluency practice, but I want to ask you, what are some other ways that you can practice fact fluency? You could share those with our group so that everyone has some more ideas to put into their instructional platform. I will also say, while you're sharing your fact fluency idea, is that it doesn't have to be the same every day. If you're meeting with students for intervention 4 times a week, you could have 4 different activities, one for Monday, one for Tuesday, one for Wednesday. And in fact, if you vary the way that the students practice their facts, it's a little bit more exciting and helpful for the students. Extra math, yep, student tracking over time, Shannon, that's a great thing. So students are really practicing the facts that they need to practice. Often a lot of the tracking will have students, practice a majority of facts that they know and then introduce unknown facts a little bit over time so it's not too overwhelming. Reflex math is great. I know Prodigy has the fact practice. Let's see. Dreambox has fact practice. Spring Math has fact practice. There's many out there. So we just have to access them and then make sure we're using them regularly. Playing cards, yeah, playing more. You can multiply the numbers, add the numbers. So many fun games. There's also games like chutes and ladders. You can actually think like, oh, I have to go 6 spots from spot 7, so 7 plus 6 is 13. I mean, there's many different ways that you can play games and incorporate fact practice as a part of it. You can do fact practice bingo. So many great ways. So then as we are building our fluency, it's also important that we practice problem solving instruction. This is going to be a very brief review of this. This problem solving is quite involved, but the idea is that we can't leave problem solving just up to the student's imagination, and we can't just get to it if we have time. It really has to be an integral part of our instructional platform, and I would really argue that the mathematics should be taught through problem solving, that we're always problem solving, and that's how we're teaching the mathematics so that students can be really strong problem solvers. So I'll just mention 3 things here today to kind of whet your appetite about problem solving. First is in terms of the teaching of problem solving. There's really 2 things that don't have an evidence base, but sometimes we'll see these things used in schools. And so I present them here. They have red X's over them, so they are like, don't do this. On the left-hand side is a keyword poster. Some people will teach problem solving by saying, hey, whenever you see this word, that means you do this operation. That's a really ineffective strategy. We did a study, it works about less than 9% of the time, so I wouldn't teach it because there is no single word that always means the same operation. So that's not a good strategy. And I think as Corinne was talking about earlier in terms of high school math, that might work really well in 1st grade. Like whenever you see total, that means you add, but that totally falls apart in 2nd grade. So don't teach something a keyword that's tied to an operation. And over here on the right-hand side is an example of an activity where what is every student going to do on this page? They are all going to subtract. So like there's never a problem solving situation that students are faced with where they're told, hey, this is a subtraction problem. Like that just doesn't happen in real life. And so we shouldn't engage students in activities where ahead of time we tell them what to do. Because if I say you're going to subtract on all these problems, you don't have to read the problems, you don't have to think about them, you don't have to interpret them. You're just going to subtract here the greater number minus the lesser number to figure out the difference. And so there's really no thinking involved, and that's not actually problem solving. So let's not engage students in activities such as that. But instead, we should teach students to have an attack strategy. I'll give an example of that on the next page. and teach what we call the word problem schemas. That's going to help students really understand what word problems mean. So attack strategies are examples such as this. This is ride and ridges. Notice in both of the attack strategies, there's slight differences, but the first thing that students do in both is that they read the problem. Because I don't know about students in Pennsylvania, but students in Texas, that is not the first thing that they always do in word problems. So a good attack strategy is going to get students to sit back, read the problem, and then work through the word problem step by step. Here are two other popular attack strategies, solve and cubes. A lot of schools use cubes. If you're using cubes, please just turn it into R cubes. It's not as cute anymore, but read the problem and then you can circle the key numbers and underline your question and that type of thing. And the attack strategy that I favor, we use this the most with our students here, is UPS check. It's very general, works across grade levels, and can be used for numberless word problems, for word problems with fractions and algebra. It can be used all over the place. So I really like the UPS check strategy. And then in terms of the schemas, there are really 6 structures related to the operations that we see time and time again through word problem solving. And a lot of this comes from, some of you might be familiar with like cognitively guided instruction. A lot of this comes from general education, but then it's been tested in special education or in targeted and intensive intervention, and we know is really effective there. But here we see that if we see these schemas, then student can like recognize that schema and they're like, oh, I know how to solve this problem. I have solved a problem like this before. So in total problems, there are parts that are put together for a total. In difference problems, which sometimes are called compare, we compare amounts for a difference. In change problems, there's an amount that increases or decreases. In equal group stories, you have a group with an equal number in each group. In a comparison story, you have a set that's multiplied a number of times. And then in ratios and proportion stories, you either have a ratio or a proportion where you're comparing if this is to that, then this is to that. And they're very consistent. And so if you've solved one proportions problem, you've solved them all, right? But if students can recognize that as proportions problem and maybe they have a graphic organizer or they have a way of setting up that problem, it makes word problem solving much more accessible. So as I think about word problem solving, I want to see if there's any other attack strategies that you favor or you use. I know a lot of people do use cubes and a lot of people use UPS check, but if there are any others out there, I'd love for you to share them with the group right now so that we can benefit from those other attack strategies. And with attack strategies, I'll always say that I don't particularly care which one you use, I just care that you have one. And if your whole school adopts it, even better, so that you can move from one grade level to the next or one setting from like universal intervention to targeted intervention. The same attack strategy is always being used. So there's a lot of consistency there for students. So I'll pause to see if anybody else has any attack strategies. Okay, so as we, just to review for today, when we think about the delivery of our targeted intervention and of our intensive intervention, we really want to think about our instructional platform. We designed this instructional platform thinking about how we're going to deliver instruction. So we should think about explicit instruction paired with precise language and bringing in multiple representations when students really need to understand the math. But then every day that we're using that instructional platform, how are we building fluency and how are we helping students problem solve? So that they get these things all the time. This is what we do. This is our core. And then if students need adaptations to the instructional platform, we adapt these 5 components, or maybe we bring in a 6th component. We never leave these behind because they're really our core, but we're going to adapt how we do the explicit instruction, how we focus on language, which multiple representations we bring in, and so on. So if you do want some more information about the designing of targeted and intensive intervention, I put together, along with the National Center for Intensive Intervention, what we call a math course. This is totally free. It's presentations and handouts and a ton of free videos, but it's really how to do what we've been talking about in this webinar today. If you go to the math course, there are 8 modules, but there are 2 that are really integral to our information for today, and that's modules 4 and 5, and you can see 4 is about instructional delivery and 5 is about instructional strategies. So especially if you want to know more about those word problem schemas, module 5 part 2 has almost an hour video that shows all 6 word problem schemas, the different types of word problems that are represented by those schemas, and how to teach students to solve the word problems by those schemas. And then also, if you are, I think this book might be available to some of you participating today. This book was about teaching math in middle school, but I would say that it's definitely pertains at high school and also at the elementary grades. A lot of our math examples are from middle school, so this is an example of a proportions word problem here. But we talk about fluency building, and we talk about problem solving, and we talk about explicit instruction, and those things are absolutely essential at all grade levels. So if you can get your hands on that, a lot of the information that we talked about today is in that book. And so I'll finish there just a few minutes early to give us an opportunity to ask any questions. Do feel free to reach out via email. I can send you more resources or answer any questions, or we can talk more about math at your school or in your classroom. And do feel free to find me on Twitter. I'd love to become your math Twitter friend. And then we can tweet about all the cool math things. So if you're signing off now, I do want to thank you so much for your time today. I know it's late in the afternoon, so thanks for tuning into this webinar, and I'll stick around for a few minutes and answer any questions that come into the chat box. So thanks, Corinne and Carolyn. Have a good day. Enjoy the rest of the summer, although it seems like it's fading fast. Let's see if any questions come in.
We just want to thank you so much for your time today from the
Thanks,
LIU.
Lori.
We really
Thanks.
appreciate that.
Yeah, no problem. It's been fun, and I'm happy to be a resource when anybody wants to talk more about math.
I have used a lot of your intervention videos, that math course that you have.
Oh, great.
I have
Yeah.
shared
Awesome.
that with so many people. We were actually working with a district who was developing their curriculum last year. And I was
Okay.
like, you have to look at this.
That's great. Yeah,
We
it's
were working with their special ed staff. So
super.
yeah,
Okay,
really.
I'm so glad people we know, I mean, we know the views on some of the stuff are pretty high, so it's really great to know that we spend a lot of time in a recording studio and that people can actually use that information. So that makes me happy. Thanks for sharing that. That's great. So, well, it doesn't seem like there's any questions, so I'll go ahead and sign off, but thanks so much for helping host this afternoon, and I hope you have a good rest of your day.
All right. Thank you.
Okay. All right. Thanks, Lori.